a nice selection from the video vault. We definitely get some beautiful skies out here in Texas. Anyway, hope you enjoyed that. Let's look at the surface chart for this afternoon. For today's map, I actually used potential temperature. I had some difficulty finding the front back here in the southwestern U.S., so I used that to kind of verify that the cold air mass has passed Arizona and Utah. Temperatures do seem a little bit cooler out there. 86 there at Phoenix, 68 at Gallup, which is pretty cool, and you contrast that with 88 out at Roswell and 93 at Midland. So this is almost certainly in the warm air here. And yeah, with that 74 in Albuquerque, that's pretty cool for this time of year, and probably got the colors reversed. But anyway, that's the warm air and that's the cold air. Now, another good indicator of frontal passage is if you look at the ridge formed by the theta, or potential temperature. That ridge kind of runs through about here. This is kind of like a thermal ridge where the max heating is found. And we notice that it's centered on the high plains of New Mexico. Now, normally we see that theta E ridge, or I'm sorry, that theta ridge on the Four Corners area, or out in Arizona, or somewhere out in the Central Rockies. But that's not what we have today. It's displaced out on the plains, and that indicates that there has been some cooling, no longer getting that very intense heating in the Great Basin and Rocky Mountain region. Now, if you don't want to use digital atmosphere, you can go to SPC. You go to their experimental analysis page, and you can pull it up right here. There's the mixing ratio and theta. It's a little bit more noisy, but that kind of bears out that theta axis running about like that. So it definitely is displaced, and I think we can even pick up the front a little bit. See how there's this packing of theta lines right there? That's probably a thermal gradient, and so I'd be looking for the front somewhere in here. And based on that temperature there at Albuquerque, I might even extend that a little further east. So got to be kind of right in that area. And that brings us to our standard surface chart. Frontal system in southeast Colorado, they're near Springfield, with a warm front extending down towards Shreveport. North of that, the air is fairly well modified in Oklahoma and Kansas. But down to the south, the southerly flow is going. We've got the Gulf open, and we're bringing up 70 to 75 degree dew points. The dry line is also active, becoming pretty well defined along the Caprock down towards San Angelo. And of course, as we mentioned, a cold front in New Mexico, but it has weakened quite a bit from a couple days ago when it was in California. Up to the north, a very well-defined system there in the Canadian prairies, bringing another shot of cold air down through Calgary into northern Montana there near Great Falls. This zone right here across western Montana is going to be within that cold convection zone. We got that cold core vertically stacked barotropic system there. Now, what's interesting is you remember how we had that cold air factory in Quebec and Maine and New England. Now look at it. We've got 80s all across that region, 81 up there in Caribou, and lots of 80s through Montreal and those little towns up there to the north, and 80s across Ontario. So that's a huge, substantial warm-up. But the cold air is lurking right up to the north there, 1030 millibar high, coming in across western Hudson Bay. And you can see we've got blizzard conditions going along the western coast of Hudson Bay there. All right, so we can take a look at tropical tidbits. There's the GFS corresponding to the current time. Now, to place those systems, I'm going to go with the northern plain system since it's a little bit more well-defined. So the warm front looking like that. What I'm going to do is I'm going to draw a cross-section from western Montana out into the warm air. So let's give that a try. So we just do a control and then drag the cursor, and we get our cross-section. Now the wind, the upper level winds should be blowing that way across our cross section, so we're going to use the normal wind, so that'll show air blowing in and out of the cross section. It's very tricky using winds with cross sections because they're often not aligned with the cross section itself, and you kind of have to be thinking three-dimensionally. So here we're looking at the component going in and out of the page, and the winds up there should be mostly dominated by that kind of wind. What we see here, looking along the surface, we can see the cold air right there, see the lower potential temperature values. That's going to be cool air, and then the warmer air is out in this region here. And then we go further east, and then we get back into the cold air once again. So this kind of looks a little bit to me like something like that. So that's the front right there. Then we can see the lower tropopause out to the west over Montana, and then the higher tropopause out to the east over the Great Plains. And we can see that that jet stream, polar front jet, sitting right over that frontal boundary where it should be, and that's always going to be to the cold side of the surface fronts. So this is the main baroclinic zone out in this region here. So what I like to do is use these to kind of verify the frontal placement. And it can also help me visualize the structure in the atmosphere. Let's take a look at relative humidity. There we can see some of the lift out ahead of the front there, and it looks like it's picking up some of the cold core convection back further to the west. Now the blue lines here, these are not potential temperature anymore, these are theta E. So that's going to be factoring in moisture quite a bit. So I'm not going to worry too much about that. Yeah, there you go. There's how you can use cross sections. Now I did use it to kind of figure out what was going on in this region here. I'm trying to pick apart that front there in New Mexico. And let's see, what did I get? I did something like that right there, going from Vegas to about DFW. And yeah, we can see that jet there over Albuquerque, but the frontal surface is very indeterminate. Maybe something in here. It's really, really hard to say. So anyway, yeah, I'm probably just going to go with an assumption that it's kind of in that area. And we're not going to see the dry line on this without absolute moisture quantities like dew point or mixing ratio, and that's not part of the setup here. Tropical Tidbits does give us the high-resolution rapid refresh as well as zoomed-in sectors. So let's take a look at that and see what we're forecasting. So starting out, we've got to make some assumptions where our fronts are. Remember, we were looking at something like that there. Cold front like that, and it looks like we're already at the very beginning breaking out some activity there northwest of Waco. So moving forward, convection initiates around 4 p.m. out in southwestern Kansas, and it looks like we get upscale growth into a MCS after dark. So by midnight, that's moving through the Dodge City to Pratt area, and then towards dawn into the Stillwater Enid area. And then usually around dawn we start seeing dissipation of MCSs, but this one keeps going, keeps advancing eastward into Missouri. So we can tell already that later tonight that's probably going to lay down a boundary somewhere in this area, and that would be available to any storms that form in that area tomorrow. Anything else going on? Looks like the convection there in central Texas is kind of disorganized more in the Paris area, and those appear to be mostly diurnal. Little late convection in the hill country there near Mason and Fredericksburg. That's actually more towards Brady, and that dissipates. And that is about it for tonight. So the next thing that you want to kind of do is go back to the beginning of convection and look at the storm environment, like what kind of cells are we going to have, say, around Dodge City. So let's look at the environment that these cells are getting, say, around 7 p.m. We're going to look right around, I guess that'd be around the Dodge City area. Look at our forecast sounding there. Well, it looks like we have some dry air infiltrating into those storms. You can see the capping is kind of weak, so that means numerous cells, a lot of cell competition. And the LFC looks to be pretty high, up above 10,000 feet. So a lot of the strong parcel accelerations are going to be at least 2 to 3 kilometers up there. We do see some decent shear there from 0, not particularly 0 through 1 kilometer, but 1 to 2 kilometers. We do see some decent shear coming together there. 0 through 2 kilometer band there. Not so much 0 through 1. However, a negative factor I'm seeing here is the high decape. This is going to indicate very gusty winds coming out of these storms. And that's, again, you know the story. That's going to rapidly undercut storms and give us something like what we had last Friday in northwest Texas. Kind of a very similar setup. Yeah, you can see the storms initially, they're coming together in an area with weak dew points. The better dew points are out around the Pratt and Dodge City area further to the east. And it looks like only late do those start intersecting the cells, kind of like after dark. So let's check out the Dodge City area around 10 p.m. Yeah, better moisture coming together there, better RH. That can be better for tornadoes. And wow, look at that shear there. Now, normally if we had a little more cape, or a little more capping inversion, I would be thinking of tornadic cells, but the other problem is, again, the decape is up very high. A lot of that dry air being transported down to the surface. And also the weak capping, that's very weak capping, which means numerous cells going up everywhere. So you're going to be dealing with mostly an MCS, and it's hard to get a good isolated storm going within that line. It's possible something could come together somewhere in there. I wouldn't totally write it off if I was chasing, but the environment does have problems, and the better ingredients don't come together until later. All right, checking in on our environment, we've got storms forming in the Lamar area. There it is right there. Let's run that back a little bit and we'll see the area come together. See, starting out, that looks like the front right there through the Guyman area. And the warm front doesn't show up so much. We figure it's probably back in this region. And maybe that's probably the dry line going right down the cap rock. It looks like another little boundary kind of moving through there. Let's run that forward. This is going to be about 1 p.m. Central. And you can see the northerly flow coming down the backside of that front. Little convergence axis. And the storms form along that boundary. So there it goes right there. This is 4:06 p.m. And let's bring that up to the latest frame. Yeah, even Trinidad seems to have some stuff going up there out to the Raton Mesa on the higher terrain. Some cells in that region. And notice that the anvils are being carried to the northeast. So that's going to deposit a lot of the precip up that boundary and reinforce that. So usually when you have your anvils being lofted like that along the boundary, that forms up an MCS. That's probably what we're going to see today. So you'd probably be chasing the tail end storms if you were happening to be out there. That's a pretty good overshoot right there. Let me see if we can zoom in on that. As Captain Picard says, enhance. Let's check it out. Yeah, that's a nice little overshoot there. Pulsing, looking really good. And this other cell, I'm not sure what's going to happen to that. That's kind of doing its own thing out there. And at this time, it's probably, you definitely want to supplement your radar with this, because this is going to be at the max range of the Dodge City radar and the Pueblo radar. So your satellite can kind of fill you in on some details you may not otherwise see with ground-based radars. And then a quick little look down in Texas. The models were trying to develop something right in that area. I don't see anything there at this time, but some enhanced cumulus elevated out along the dry line. So I think this could be an area that could come together in the next few hours. But I think this is going to be kind of a low shear environment. Yeah, it looks like that high-resolution rapid refresh. No longer developing anything near Waco and going for something around the... looks like around Anson to Jayton, somewhere in that area. We'll just look at that environment very quickly. And you can see it's uncapped, which means numerous cells if we get enough convection boiling. Low shear in the low levels, and the upper levels also low shear. So we're getting about 20 knots of storm relative inflow, which is good. The problem is there's not much curvature on that photograph. Look at those SRHs. They're just down in the gutter. And what's the values here? Yeah, 25 to 100, that's not great. So it would be kind of a tall order to get storms rotating in that area. You would need something probably to back the winds a bit, bring them around to the east. And I don't think we're seeing that. There's not a mesolow. Maybe a little bit of backing kind of in this area around Knox City. That could kind of boost your SRH just a little bit, but not so much south of that region. So yeah, if I was forecasting, I'd probably be picking out a little boundary along there and watching anything that happens along it. Okay, yeah, I wouldn't totally rule this area out. If I was in Abilene still like I was many years ago, I'd probably venture north just in case. You can see the timeline shows we're up to 15 minutes, and I want to try to start getting these down to 15 minutes. So I think over 20 minutes things get a little bit more, it just kind of drags on, and I know some of our more casual viewers would probably get bored with programs that length. So let's go ahead and wrap things up. Let's see, do we have any new patron subscribers? Well, sort of. No new subscribers, but Keith Brandt upped his pledge, and I appreciate that. And that's it for today. I appreciate you all watching. We'll be back again tomorrow. It is Friday coming up here. And I guess is that Memorial Day weekend? Yeah, it is Memorial Day. So, yeah, that's coming up, but we're going to stay on the same schedule. Okay. So everybody have a good evening, and we will see you tomorrow. Bye-bye.